What's up everyone, welcome to my channel. Recently I just finished my AP Biology exam and I wanted to try my hand at making some videos to make the review more easier for you because I have felt the same pain that you guys probably feel right now. Shoot. All the things that I will say will come off from the 5 Steps to a 5 AP Biology book, and I highly recommend that you get this book even though it does have its flaws, such as going into rather random tangents that you most likely don't need to remember. But it is still the book that my biology teacher recommended me, so I would recommend you to get it as well. This video will be the first of several addressing the entire biology course, so any questions that you have, please put it in the comments or just ask your teacher because he or she will definitely be much more qualified than me to answer them. Also, these videos are in no way sufficient to pass biology or the AP exam. You should do active studying, which means taking notes while watching my videos, taking notes while reading, watching crash course videos, and doing Quizlets. My videos should not be the place where you go to learn these concepts. They should be more of a refresher than an actual class. So you therefore have to stay attentive in class, and you still gotta listen to your teacher. Even though I know how you love to hear my voice, you still have to listen to your teacher. Can be hard over virtual circumstances, or even in person. Just stick with them. I promise what they say will be helpful in the long run. So, if you guys are ready, here we go. The main focus of Chapter 1 is the chemistry of life. So you may be asking, why are we doing chemistry in biology? Well, the truth is chemistry and biology are intertwined. And the first thing that we have between them that is connected is atoms. Atoms are the most basic subunit of chemicals, where nothing can be divided into a more smaller, scientifically proven form that still holds their characteristics. In the periodic table, for example, atoms are divided into something called elements. More on that later, but this is very important. In short, atoms are the smallest unit of the universe that can still retain its chemical, elemental properties. And what makes it that chemical? Now, what makes up atoms? Atoms are the smallest unit, but they are still made up of subatomic particles. These are extremely small particles that are the same within one another. There are three different types of subatomic particles, and the first of which I will address, is protons. Protons hold a positive charge, and they have a weight of 1 AMU, or 1 atomic mass unit. These are found in the nucleus of the atom. Secondly, there are neutrons, which hold no charge, and they are also found in the nucleus of the atom. They also have an approximate weight of 1 AMU, atomic mass unit, and are used in dealing with isotopes and the atomic mass. More on that later. And lastly, there are electrons, which hold a negative charge, and they have a weight of, if you really wanted to be specific, 9.05 times 10 to the negative 28 grams. You do not in any way need to remember that, just a fun fact. These electrons are found in the rings of the atom, which orbit the nucleus. With these three subatomic particle types, there has to be a force keeping them apart and together, right? Because you know gravity. Gravity likes to kind of keeps things mushed together as us staying on the planet Earth don't go into space and all that. So gravity is a force that usually most people know. But there are other types of forces, and in this case, atoms have a couple of forces. First type of force that I will address is the strong nuclear force. This just keeps the protons and neutrons in the center of the atom without them shooting off. Secondly, we have electronegativity, which means that electrons and protons will stay at a certain distance in a stable orbit because opposites attract, but the strong nuclear force doesn't let them connect. Lastly, the weak nuclear force is a determinant of how much the atoms decay, where pieces start falling off because the atom has too many pieces to really care. You can just kind of lose them along the way, kind of like you lose pennies on the stairs. Now, for each properties of individual atoms, we have several equations. First of which is the atomic mass. The atomic mass is, simply put, the addition of the protons and neutrons. For example, if we have hydrogen, one proton sometimes 1 neutron, its atomic mass can be 2 or 1 because it might not have the neutron. Secondly, the second thing that we have to account for is the atomic number. The atomic number is just the amount of protons. That's it. Thirdly, we have to address isotopes. Isotopes are usually unstable forms of their original form. So what do I mean by that? For example, if you have a carbon with 14 protons, 14 neutrons, 14 electrons, a stable carbon. If you add 2 neutrons to it, it will become an isotope of carbon-14, known as carbon-16. The only thing that differs from its original form of an isotope is that it's a neutron. Neutron counts are different, and atomic masses are different. That's it. The atomic number does not change in an isotope. It always has to have the original protons. Alright. Lastly, there are bonds between atoms. So there are 2 types of bonds, ionic and covalent bonds. So how do these bonds form? And this is very key to understanding this, as these bonds form because of the electrons. In ionic bonds, metals and gases, for example NaCl, will transfer their electrons from the molecule with the lowest amount of valence electrons in its outer shell. So for example, in this case, as I said, NaCl, Na only has 1 valence electron, and that valence electron will therefore be transferred to Cl. And this is because molecules or particles really do not want their outer electron rings to be empty. They want them to be filled or completely gone. So in this case, Na will get rid of its electron and get rid of its valence electron shell, and Cl will have its electron shell filled. Okay, so that's ionic bonds. Now, covalent bonds are bonds that happen when electrons are shared between atoms. The electrons are not transferred, completely given up to another chemical, but both of them kind of hold it between them. These bonds usually happen between gases or 2 chemicals of the same element. These bonds are responsible for molecules such as H2O and O2. Other notable bonds include hydrogen bonds and sulfur bonds, but they will all be things that I will cover in the coming videos. So, this is again part 1 of the chemistry of life, the very basic of chemistry, so that the next time, the next episode, we will be able to launch straight into the chemistry of life, about groups, about compounds, and many more that's covered in chapter 1. So this is Turbo T, and I am going out. Keep an eye for the next one, and I hope this video really helped you study. Good day to you, mates, and I'll see you in the next one.